Hi, it's Chris Moberg again, and I'll be bringing you the next installment in the Quantum Training Series. Today we'll be looking at the various run types within Quantum, starting with the gear roll. But before I get going on that, let me give a disclaimer that the run types you see listed here may not be available to you depending on your license type. And second, if you don't have an eddy brake, some of these run types will not be available to you. But everyone will be able to do the gear roll-on, the first one in the list. You can do this whether you have an inertia dyno or a load-bearing dyno. The gear roll-on is what I'll call the bread and butter of dyno operation. This is the one that you're going to use on dyno days, for baseline pulls, and for watt pulls when you're doing tuning. It has as options load if your dyno has an eddy brake, and load can come in these various types. I've discussed those in another training video, so I'm not going to spend any time on those today. And so we'll just jump back out of that and look at the next run type. It's the negative run, or coast down. A coast down run is one designed to calculate drivetrain loss. And you do this by accelerating the vehicle to a target speed. This would be associated with sort of the maxed RPM that you're going to be using or testing with. You put it in neutral, hit go, and let it coast down. You do not touch the brake, you don't touch the clutch, just let it coast down in neutral. When it gets to 30 miles an hour, you hit go again, and then Quantum will compute the drivetrain loss. And once it has that, it can convert the horsepower and torque at the wheel to horsepower and torque at the engine. This is very important in the world market, where engine numbers are what's desired. In the U.S. domestic market, it's not as popular, and most of the time you're going to be dealing with at the wheel numbers. And we'll look and see what we have on the next screen. There aren't any details you have to set with a negative run, so we'll just pop out, go to new run, and look at engine power. Well, engine power is really the combination of the previous two types. It's going to give you the ability to do a gear on roll on the way up in speed and RPM, and then it's going to couple that with a negative test on the way down. So it is a simple way to get both a power reading and a drivetrain loss reading all in one test. You do this by hitting go as you normally would with a roll-on. You go to your terminal speed or RPM, hit go, put it in neutral, coast down, hit go again. From that point forward, in that session, we'll have engine horsepower and torque available to you, and you can use gear roll-on tests for additional testing while maintaining engine and chassis numbers available to you. All right, so then let's see what we have on the next screen. You can apply load, because this is essentially a gear on roll on the way up. So you can apply load like you can on the basic test. On new run, we'll go to the speedo test. Speedo test in tuning is useful if the vehicle has non-stock tire size. The speedo test will allow you to see the variance between the vehicle speedometer and the roll speed. This then would allow you to go in and change the ECU calibration on speedo gearing. Other uses would include working with local police departments to calibrate the speedos in their cruisers, or working with local lawyers to calibrate their speeding clients' vehicles to try to beat speeding tickets. So you probably want to choose one side of that group to deal with. And let's see what we have on the next screen there. And you can see that we set up various characteristics for the test. I should mention there's a nice report you can generate for this as well. Important things are the min and max mile per hour that you're going to go from and to on the test, and the stepping of the miles per hour. And I'm not going to spend a lot more time on this because it's not available in all versions and it's not really related to tuning so much. Excuse me. New run. The race simulation and measurement. We basically have an ability to do a 3D animation for our visual display of the pull. This is just a different way of looking at the pull, and we can look at what characteristics you set for it, and basically the race type you can do from a dig or from a roll. You can put in the weight. If you're not doing one of the fixed tests, you can go for min and max test speed. You can enable VRS. I haven't talked about that yet, but remember you can enable it or run without it on the race simulation. So let me move on from there. Segue into the virtual road simulation, or VRS. So VRS is the way in which you can simulate real world driving. As you may realize, on the dyno you don't have wind resistance, and the mass of the vehicle is not necessarily represented, typically not actually, in the inertia of the roll. So with virtual road simulation, it can add in eddy force to compensate for the lack of those environmental factors, giving you a duration, an acceleration rate that is very close to what you would achieve on the street. A use for this is after you've done your tuning and you know you're looking to do the final confirmation of your tune. Basically, in the past you might have taken the vehicle off the dyno, gone on the street. With VRS, you don't have to take it off the dyno. You can do a VRS test and be confident that if the tune is good in VRS, it's going to be good on the street. So this improves your operational efficiency because you don't go through the unstrapping and then having to restrap if the tune needs to be modified. So I would say good for conformance after you're doing traditional tuning on the dyno. I don't tune with VRS enabled. I mean, you could. I don't. And then I use VRS as a final step. So let's look at what parameters you have with VRS. Okay, so VRS, you really have 3 different variants that you can use to control the mathematical model for the simulation. The first, listed on the top here, is the vehicle parameter model, or the parameterized model. This one is the most accurate. It has all the characteristics of the vehicle as it's driving through the air and on the road. But you may not have all of these numbers. And that leads to the other 2, which are EPA related models. And if you've chosen your vehicle during your create session from the drop-down list, the manufacturer, the model, the year, then these ABC coefficients will be filled in, as will the power at 50. And so you can choose either ABC or power at 50 to do the test. These are just different models. One of the Dynacom competitors that has a simulation, theirs is done using power at 50. So you can do a test like they do, but you have two other ones as well. So you just have to choose the test you want to do. They both run in the same amount of time. The amount of force they do will be very similar. And then lastly, let me just close out saying the VRS correction factor. If you have knowledge that this vehicle, through its drag racing or street timings, goes from X to Y speed in some amount of seconds, and your VRS pull is not, maybe it's off by a quarter or a third of a second, something like that, you can use your VRS correction factor to scale it up. So if you increase VRS correction more than one, the acceleration time will be lengthened. If you make it smaller, then it will be shortened. All right, so let's move on then, and we'll go to the family of runs here at the bottom, the things that start with PAU. All right, so first of all, these are all the ones that you absolutely have to have an eddy brake for. And before I get into talking about the specific test, I recall that someone asked on the forum, what's the difference between a constant test and static load? All right, so let me just explain that now. Static load, which is available to you on the gear roll-on and the engine tests, is, we'll call it, an open loop control. It is Quantum telling the eddy brake, run this duty cycle. Okay, and it's open loop because it never tries to measure what force is being generated by the eddy brake and use that to control what it's asking for. Okay, a constant test is a closed loop test. It will hold either speed or RPM or load constant in a closed loop model. So it will initially send a commanded duty cycle. It will look at the variable that it's monitoring, say speed, and if the speed is going higher than target, it will increase the duty cycle. If the speed is lower, it'll decrease the duty cycle on the eddy brake. So this is what I mean by closed loop, that it is using feedback of the monitored variable, speed, RPM, or load, and you might get an inkling that this is the same settings that we have in mode 1 on the handheld. And I'll take a sidebar here and say that the way Quantum works in these PAU modes is to send parameters to the handheld/DC controller that are used for the running of the test. So think of Quantum being the master of ceremonies, the controlling agent for the test, but in these PAU tests, the down and dirty manipulation of the eddy brake, the monitoring of the speed, the feedback loop. The closed loop part is all happening between the DC controller and the eddy brake and load cell. So the point of that is we're not going up the USB cable. We're not going into Quantum. We're not fighting with other things that are going on in the computer. This is a hardware solution that is running in the DC controller as a sole purpose of that controller. And so this is very, very much superior to trying to control from the PC. And that is a key part of the design of your Dynacom dyno. And so we'll look a little more deeply here at the constant test. So okay, so it is constant in that it's going to keep speed or engine RPM or force constant, and you choose at what speed or RPM or load that you want to keep it constant. And you can set a test duration. It will run the test for this amount of time, and you'll see that the speed, if you look at the graph when it's done, is going to be very much constant. So that is, I look at constant. So let's now look at the step test. Okay, so a step test is one that runs from X speed to Y speed, or start speed to end speed, start RPM to end RPM, by some step with some duration that it spends on each step. And so this is a way you can actually tune in using Quantum rather than Mode 1 by doing step tests at different throttle positions. That basically the step test will, you can hold throttle steady and run the step test, and it will step through different RPMs, and so you'll cut across your fuel map. Whereas when you're doing Mode 1, you're typically going up load and then stepping to another RPM and going up columns. So this is going to go across rows, where Mode 1 goes up columns. So you just can do different rows in this model rather than columns in Mode 1. The advantage here is you get to log the data. This is not as effective if you have a real-time tuning capability. I would recommend Mode 1's, steady state and RPM on the handheld. But if you're doing a flash tune where you're going to log and then make changes and based on the log values and then reflash, this is a very effective way to do that. New run, ramp test. Ramp test is just linear acceleration. If you have a turbo vehicle and you run it, just inertia, it has, the torque is very nonlinear and the acceleration is nonlinear. If you want to have linear acceleration for uniform measurement of horsepower or torque, you can use a ramp test where the eddy brake will be used to ensure linearity of the acceleration. It's controlled by start value and end value and a test duration. This is a pretty fast test. Doesn't heat the eddy brake or the car that much. A point I should have made on the step test. that's going to heat your eddy brake up quite a bit, and it's going to heat the car up quite a bit. So when you're choosing your duration, the time to spend on each cell, or each step, excuse me, you have to do that with consideration of settle time for the fueling and heat developed in the engine. And lastly, we have the PAU custom test. Not going to talk a lot about this one, other than to say that it is a parametric test. It is one where you define the shape of load application. So if you had that turbo vehicle that had a very sharp boost curve and therefore sharp torque curve, you can match your load curve to the torque curve with the program force or custom PAU test. This is useful if you're trying to provide load where torque is at a maximum. If torque falls off in a non-linear way, you're not effective when you try to do it with interpolated load, because interpolated load is linear, either linear up or linear down. So it's assuming more of a straight line build or fall off of torque. And if your torque doesn't build or fall off that way, then perhaps the custom test is for you. And so with that, it concludes the overview of the load or test types in Quantum.